Am I the only one that didn't know teleportation has been a part of our imaginations for decades? From Star Trek to Star Wars, science fiction has long captivated our imaginations with the idea of teleportation. Imagine stepping into a booth, pressing a button, and instantly finding yourself on a distant planet or in a bustling city across the globe. No more long commutes, no more airplane delays, just pure instantaneous travel.
Teleportation in its most basic sense is the ability to transport matter or information from one point to another without physically traversing the space between them. It's a concept that has fueled countless stories, sparked scientific curiosity, and left us wondering if such a feat could ever be possible outside the realm of fiction.
While the idea of beaming ourselves across vast distances might still seem like the stuff of fantasy, the science behind teleportation is surprisingly complex and rooted in some of the most mind-boggling concepts in physics. Join me as we delve into the world of wormholes, quantum entanglement, and the tantalizing possibility of making teleportation a reality.
Before we can explore the possibility of teleportation, we need to understand the science that might make it possible. Two key concepts lie at the heart of this exploration: wormholes and quantum entanglement. Wormholes, often depicted as shortcuts through space-time, offer a theoretical means of traversing vast distances in an instant. Quantum entanglement, on the other hand, introduces us to the strange world of quantum mechanics, where particles can be linked across vast distances, their fates intertwined in ways that defy classical physics. While these concepts might sound like something straight out of a science fiction novel, they are grounded in real scientific theories. Wormholes emerge from Einstein's theory of general relativity, which describes gravity as the curvature of space-time. Quantum entanglement, though equally mind-bending, has been experimentally verified and forms the basis for emerging technologies like quantum computing.
Imagine folding a piece of paper in half and poking a hole through both layers. This simple analogy helps visualize the concept of a wormhole. In essence, a wormhole is a theoretical tunnel that connects two distant points in space-time, allowing for travel between them faster than the speed of light. These cosmic shortcuts, if they exist, could provide a means of traversing vast distances in the blink of an eye, potentially even allowing for time travel. The idea of wormholes arises from Einstein's equations of general relativity, which suggest that massive objects warp the fabric of space-time. While the mathematics allows for the existence of wormholes, creating and stabilizing one presents enormous challenges. The amount of energy required to create and hold open a wormhole is thought to be astronomical, far beyond anything we can currently generate or control. Assuming we could overcome the technological hurdles of creating and stabilizing a wormhole, what would it be like to travel through one? Some scientists theorize that a journey through a wormhole would be a disorienting experience, a whirlwind of distorted light and warped gravity. Others believe that passage through a wormhole might be relatively uneventful, like traveling through a tunnel, with the destination appearing suddenly on the other side. The nature of time itself might be different inside a wormhole. Einstein's theories suggest that time is relative, affected by gravity and motion. Traveling through a wormhole could potentially allow for time travel, either forward or backward, depending on the wormhole's configuration and the traveler's trajectory. The implications of this are profound, raising questions about causality, paradoxes, and the very fabric of reality.
Quantum entanglement. Spooky action at a distance. On the quantum level, the universe behaves in ways that defy our everyday intuition. One of the most bizarre and intriguing phenomena in quantum mechanics is entanglement, a phenomenon Einstein famously dubbed spooky action at a distance. Entanglement occurs when two or more particles become linked, even when separated by vast distances. Measuring the state of one particle instantaneously determines the state of the other, regardless of the distance between them. Imagine flipping two coins that are quantumly entangled. If one coin lands on heads, you instantly know the other coin will land on tails, even if the coins are light years apart. This instantaneous connection between entangled particles has been experimentally confirmed and has profound implications for our understanding of the universe and the potential for teleportation. Teleportation through entanglement, from particles to people. The instantaneous connection between entangled particles has led some scientists to explore the possibility of using entanglement for teleportation. The basic idea is to entangle a particle at the sending location with a particle at the receiving location. By measuring the state of the particle at the sending location and transmitting that information to the receiving location, it might be possible to transfer the state of the first particle onto the second particle, effectively teleporting it. While scientists have successfully teleported the quantum states of photons and other particles, teleporting larger objects, let alone humans, presents enormous challenges. The amount of information required to describe the quantum state of a complex object like a human being is astronomical. Moreover, the original object would need to be destroyed in the process, raising ethical and philosophical dilemmas.
The challenges of teleportation, matter, energy, and information. Teleportation, as depicted in science fiction, often glosses over the immense challenges involved in transferring matter, energy, and information across vast distances. To teleport an object, you would need to instantly deconstruct it at the sending location, transmit all the information necessary to reconstruct it at the receiving location, and then reassemble it with perfect fidelity. This process would require unimaginable amounts of energy, flawless information transfer, and a complete understanding of the object's quantum state. The Heisenberg uncertainty principle, a fundamental concept in quantum mechanics, poses a significant obstacle to teleportation. This principle states that we cannot simultaneously know both the position and momentum of a particle with perfect accuracy. This inherent uncertainty in quantum measurements makes it impossible to gather all the information needed to perfectly reconstruct an object at the receiving location.
Ethical and philosophical dilemmas of teleportation. Beyond the scientific challenges, teleportation raises profound ethical and philosophical questions. If we could teleport ourselves, would we still be the same person at the other end? What happens to the original body during teleportation? Is it destroyed, or does some aspect of consciousness or identity transfer to the new location? These questions touch on the very nature of self, identity, and the continuity of consciousness. The potential societal impacts of teleportation are equally profound. How would instantaneous travel transform our cities, our economies, and our relationships? Would it lead to greater connectivity or further isolation? Would it exacerbate existing inequalities or create new ones? These questions highlight the need for careful consideration of the ethical and societal implications of teleportation before it becomes a reality.
Teleportation versus transportation. Understanding the difference. It's important to distinguish between teleportation and transportation. Transportation involves moving matter or information from one place to another through physical space. Teleportation, on the other hand, bypasses the need for physical travel, instantly transferring matter or information from one location to another. While transportation technologies like high-speed trains and airplanes continue to advance, they are fundamentally limited by the speed of light and the constraints of physical travel. Teleportation, if achievable, would revolutionize our understanding of space and time, enabling us to travel vast distances instantaneously. It would fundamentally alter our relationship with the universe, opening up possibilities for exploration, communication, and understanding that are currently beyond our grasp. The future of teleportation possibilities and limitations. While teleportation might seem like a distant dream, scientific progress continues to chip away at the barriers to its realization. Researchers are making strides in quantum computing, entanglement, and our understanding of the fundamental nature of reality. These advancements, while still in their early stages, offer a glimmer of hope that teleportation might one day transition from the realm of science fiction to scientific reality. However, it's crucial to approach the prospect of teleportation with a healthy dose of skepticism and realism. The scientific and technological challenges are immense, and it's impossible to predict when or if we will overcome them. Teleportation, if it ever becomes a reality, is likely many generations away. Conclusion: the allure of instantaneous travel. Teleportation, the ability to travel instantaneously from one point to another, continues to captivate our imaginations. It holds the promise of breaking free from the constraints of physical travel, opening up a universe of possibilities for exploration, communication, and understanding. While the scientific hurdles are immense, the allure of teleportation drives us to explore the boundaries of what's possible, pushing the limits of our knowledge and challenging us to envision a future where the impossible might one day become reality. Thank you for watching Tech and Trek. Don't forget to like, share, and subscribe for more explorations into the past and future.